This is question 87, and we want to find the complete set of values of x for which x cubed minus 6x squared plus 9x minus 4 over x is greater than 0. Okay, so how are we going to do this? Well, there are two possibilities for when this thing is greater than 0. Either both the top and the bottom are greater than 0, or they're both negative, in which case the negatives will cancel and will still be greater than 0. So we have two possibilities to consider. Let's start with the first one. So for them both to be greater than 0, we need x to be positive and we need this top cubit to be greater than 0. So let's try and factorise this now so that we can work out when this is strictly greater than 0, what does that mean for x? So how are we going to factorise it? Well, often the quickest way to do this is to try and guess what could be a root. This seems impossible, it could be anything, but the likelihood is it's going to be something quite straightforward. So try 1, minus 1, 2 and minus 2 first, and maybe 3 to have a think. So luckily in this case 1 works because we have 1 minus 6 plus 9 minus 4, which gives us 0 overall. So we have a root x minus 1, and we can work out the quadratic that pairs with this by writing the brackets and then think how are we going to make each term in descending order. So we start with the x cubed. Well, we have an x, so we need to multiply by x squared. Then we also have a minus x squared term. We want minus 6x squared, so we need a minus 5x to get the remaining minus 5x squared. We also then have a plus 5x, so we need another plus 4 to have 9x, and then we have the minus 4 works out there. So we can now factorise this quadratic into x minus 4, x minus 1. So we get something which looks like this, which makes it a lot easier to see what values of x satisfy this. So now we're going to draw a sketch, because this is going to help us with the inequalities. It's often a good idea to sketch a graph. So it's going to look something like this. It's a positive cubit, so it's going to be increasing upwards overall. It has a double root at 1, so it just touches there but doesn't cross, and another at 4, which is this one here. And so we can see that this whole thing is greater than 0 only over here. This is where it's above the x-axis. So when x is strictly greater than 4. Now let's consider what happens when it's less than 0. So when x is less than 0 and this top is less than 0. We've already factorised it, and this isn't going to change just because we changed the sign, so we can jump straight to this step. Now let's have a look at our graph and work out when it is less than 0. Well, it's less than 0 in all of this bit and all the way down here. So between 1 and 4 and less than 1. Notice that you can't just write this as less than 4, because it's not strictly less than 0 at this point 1. So here it's equal to 0, so it doesn't satisfy the inequality. So we need these two inequalities here. However, we can discard this top one because we've said that we need both the top and the bottom to be strictly less than 0. And if x is between 1 and 4, it's definitely not strictly less than 0, so this doesn't work. Now, we can also override this inequality because this set says x has got to be less than 1, but we also need x less than 0, which overrides it, so we can just replace that with x less than 0 because that's a stronger inequality. And so we have these two inequalities. We got rid of this one, so we just have x less than 0 for both bits being negative, and x greater than 4 for both bits being positive. And so we get that our answer is A.